Hello everybody. Today we're going to go over our third clock arithmetic problem. The face of the clock in the tower at Westminster is 22 feet 6 inches in diameter. If the hour hand is half as long as the minute hand, compare the distances moved over by the extremity of each hand in an hour, taking 22/7 to represent the ratio of the circumference to the diameter. Now we have to remember that the circumference of a circle is equal to the diameter. And we're going to multiply by pi, but in this case, it wants us to use 22/7. Okay? So we have basically the minute hand right here. Okay? So it tells us that the clock is 22.5 inches and 22.5 feet. So I'm going to say 22.5 times 22/7. Okay? That's going to tell me how many feet the minute hand went around. Now the hour hand, it's easy to just think about 12 o'clock to 1 o'clock. It's only going to go from the 12 to the 1, okay? And it's only going to go, so if it went to the 15, the 3, it would be 1/4 of a revolution. So it's 1/3 of a quarter, 1/12, okay? So what I'm going to do is I'm going to say the diameter of the smaller hour hand like this, okay? Half the distance is going to be 22.5 times 22/7. Now let's put the 2 at the bottom. Okay, so now I basically have this whole distance circumference there. But I again have to have a 12 in the denominator because I'm only going to go from really here to here, okay? There's 3 divisions within a quarter. So it's going to be 1/4 of 1/3. So I can just put a 4 and a 3 actually. Great. So this is going to compare the distances moved by the hour hands. So let's double this. I'm going to get times 2 times 2. I just get 22 plus 22 is 44. So I get 45 times 22/7. Okay? We can easily simplify that expression because I get 5 times 2 is 10. And then I get 8 plus 10 is 18 plus 1 is 19. And then 8 plus 1 is 9. So 990/7. And this one right here, actually, so if I multiply this by 2, I have to multiply the denominator by 2. So there should be a 2 over here. Okay, so we can just half each thing now. So I get 495/7. So that's going to be, we can short divide it. 7 zeros left over. 7 goes into 5 0 times. Remainder of 5. So it goes 70 5/7 feet. That's how much the distance moved over by the extremity of the minute hand. Okay, now let's do the calculation for the hour hand. Right, this is right here is the hour hand. So multiply by 2, I get 45 times 22 over. So this 2 is going to become a 4. 4 times 7 times 4 times 3. Great. So a lot of canceling can be done here, or just, not a lot, but more than before. So this and this are going to make 15 and 1 and 11 and 2. Looks like nothing can be canceled anymore. So I get 165, 15 times 11, over, I have 4 times 7, 28 times 2 is 56. Okay, so let's do that calculation right there. 56 goes into 165. Now I can't say 3 because that's going to make it too big. So I'm going to say 2. So that's 100 plus 12, 112. Okay? So the hour hand goes 2 and 53 over 56 feet. Okay? So to summarize, the minute hand moves over 70 and 5/7 feet. The hour hand moves over 2 and 53 over 56 feet. And an important point, the minute hand moves 12 times as fast as the hour hand. Okay, that's going to be important for future clock problems. Okay.